Hi, my name is Michael, and today I'm going to talk about reasoning of LLMs and why I think that it's important to discuss it. So, first of all, let's define reasoning. I think that reasoning for this case is just solving basic mathematical problems. And you may say that, okay, how does it translate it to real world? And my answer is that logical expressions. I think that logical expressions carry the information in language. I think that without ability to process those basic logical expressions, uh, to translate text to a mathematical equation and to solve it reliably, you cannot really say that the model is reasoning. And uh, I'm going to refer to a study that was conducted by people from Apple and DeepMind, I believe, in October 2024. It's called GSM Symbolic Understanding the Limitations of Mathematical Reasoning in LLMs. And what they've tried to do is to test models on questions for 8th graders. And those questions are just basic mathematical problems where you need to translate the text to a mathematical equations and then solve them. And those equations are not very hard, they are just mostly linear equations. And they were testing how models are going to perform on them. And I think that the results are very interesting. I think that because what they've tried to do is they've tried to uh, they've tried the models on those like exact questions from the tests, and they tried to just they changed the questions a bit. They've changed names or values, or they added some unnecessary text, and they were then trying to like they were testing the models on those cases, on those questions, and the results were different, and models performed a bit worse on those. And how I interpret it is that the models were just trying to, like based on probability, just determine what is the correct answer, and the answers resembled mathematics, but only resembled. They were a lot of flaws in the reasoning, and they were because I think that reasoning is not a scale, but it's more like yes or no question in terms of like those basic problems that we are talking about right now, that the model is either reasoning or not reasoning, and there is really no middle ground, only for questions that are not uh, like defined well, and the model like made a mistake that you can justify, but the models basically performed worse on those changed answers, and I think it's because they are relying only on statistics and probability. And many people are arguing that the models will develop a reasoning on their own that, like with certain amount of training and data and scale of the model, they will just develop reasoning in some way. But I think that's really not the case. I think that we need to look into it a bit deeper because, like, large language models resemble intelligence in a way that they are basically like working with text, and that text is very good. I'm not saying that it's not, but the underlying logic is not very well, and they have a lot of flaws that are hidden behind that structure of language, and they are like using a lot of terms that like resemble that they are thinking, but the reality is that they are just working with some probability. And I think that for models to be used, or to use the models on a large scale, they need to reason. I think that this is one of the biggest problems, that right now the models are used mainly for, I don't know, navigating through documentations, through a lot of information where you need to have a, or you don't need to, but it helps to have a tailored answer just for you based on some information. But the information is not, you cannot really prove or disprove the value of the information, because there may be some errors or no errors, or it's formulated in a different way. But when it comes to mathematics, you need to be exact. And uh, and I think that they're also like used for personalized chatbots on some like e-commerce websites that will guide you through the shopping process, and they, like, it may resemble that you are talking to a real person, and you are getting recommendations that are personalized and so on. But when it comes to use cases that a lot of big companies promise to deliver, I think that they fall short on that. And I think that it will not just come up with more training and bigger models, but I think that we need to look into it a bit deeper, and to really understand how to add logic to those models so they are reliable.